Imagine a world where sunlight, once a symbol of warmth and life, becomes a silent threat, where a single bite from a newly evolved insect can awaken a chain reaction beneath your skin. Good day, everyone. Today, I will discuss a newly identified disease called Dermaphyxia pigmentosum. A brief background about us: my name is Ramilo Camille Faith, together with Surabasquez Angelo, Hunanan Kera Altea, and Manalo Hans Gabriel. We are the Bioessential Task Force, a specialized global team dedicating to combating emerging infectious diseases through biotechnology, research and development, and medical innovation. For the disease overview, this is a liquid-state dermatological disease caused by a newly evolved sandfly species, Helomia sanguinis, which produces a rare photosensitive compound called dermaphyxin in its salivary glands. Chronic exposure to ultraviolet radiation intensifies the disease, disrupting melanin balance and altering vitamin D synthesis. This leads to genetic mutations, and when exposed to sunlight, these mutations trigger photometabolic reactions, turning blood yellow-golden and causing extreme sun allergy. Let's now take a closer look at the summarized transmission pathways of Dermaphyxia pigmentosum. As we may know, Helomia sanguinis is responsible for initiating the infection. Next is the primary transmission, which refers to the initial entry of pathogen into the human body. The secondary transmission occurs through direct contact with infected skin. The third and most unusual pathway is sunlight-triggered dermaphyxin spread, which highlights the disease's photosensitive nature. For symptoms, these progress through 3 stages. In the initial contact stage, patients experience redness, irritation, mild swelling, itching, slight tingling in sunlight, and subtle pale bronze discoloration. During systematic spread, widespread dryness, flaking, burning from UV exposure, hyperpigmentation, fatigue, mild fever, and early vitamin D imbalance appear. In the severe photometabolic crisis stage, immediate blistering, pain, cracks, golden yellow blood, dehydration, persistent burning, and in rare cases, photosensitive seizures are observed. Now, biotechnology in medicine. Biotechnology allows rapid detection of dermaphyxin via swabs, skin photochromatic detectors, and blood spectroscopy, enabling early intervention. It supports targeted vaccines and advanced therapeutics like biologics, topical gels, and CRISPR-based gene correction to detoxify blood, restore skin, and provide cures. Without biotechnology, such insights would not be possible. Early detection is crucial for Dermaphyxia pigmentosum. Since dermaphyxin infiltrates skin and body fluids, rapid diagnostic tools are necessary to detect the toxin before severe symptoms develop. First, for Derma Test Kit, biosensors are engineered to recognize dermaphyxin or its metallic pigment complexes, the compounds responsible for the golden discoloration of plasma. For systematic detection, spectroscopic blood analysis measures plasma color shifts caused by metallic pigment formation, distinguishing AU-type blood from normal hemoglobin. The DPRDS includes separate rapid tools. The Dermaphyxin Swab Rapid Test, or DSRT, identifies dermaphyxin antigens in nasal or oral mucosa using a color-based immunochromatographic strip. The Skin Surface Rapid Detector, or SSRD, identifies dermaphyxin-induced pigments on the skin through dermal photochromatic reaction technology. Our group developed Dermavax, a recombinant protoprotective vaccine specifically designed to prevent Dermaphyxia pigmentosum. Dermavax trains the immune system to produce antibodies that block dermaphyxin. Other therapies or vaccines inspired by dermaphyxin include Sunshine X, a recombinant protein vaccine, Helioxin, an mRNA vaccine that delivers instructions to cells, Nanoderm, a nano-vaccine encapsulating antigens in biodegradable nanoparticles, and Crunch, a CRISPR-Cas9 therapy, repairs genes disrupted by dermaphyxin. Biotechnological approaches accelerate the development and distribution of vaccines and therapeutics through recombinant DNA, mRNA, nanotechnology, and gene editing. For therapeutic development, we have Dermavenus, Lumina Gel, and Dermalite Serum following their descriptions. Now, technologies such as AI, data analytics, telemedicine, and mobile health applications can greatly enhance healthcare response. such as AA scan, analyzes photos of the skin to detect early signs and predict outbreak areas based on sunfly activity and weather. Solar track analytics maps sunlight intensity, temperature, and sandfly activity, helping experts plan preventive measures. Telederma Network allows patients to consult dermatologists remotely, upload photos, and receive monitoring advice from home. Medisphere Smart Supply uses AI-guided delivery and drones to quickly transport medicines and vaccines to affected areas. Technology is also key in communication, education, and policy implementation. Social media, mobile apps, and dashboards can deliver accurate, science-based information on symptoms, prevention, and treatment. Interactive tools such as real-time alerts, dashboards, and educational videos engage the public and simplify complex concepts. Authorities can actively monitor misinformation and provide verified sources, reducing panic and promoting informed decision-making. Deploying these technologies raises several ethical considerations, such as equitable access, ensuring vaccines, diagnostics, and therapeutics reach low-income regions. Transparency and trust, maintaining public confidence in new treatments. Fair allocation, prioritizing distribution based on need rather than wealth or influence. And lastly, bargain of exchange. Governments must provide clear information about interventions, ensuring the public understands and consents to use. In summary, technological innovations like AI, telemedicine, and mobile health applications enhance surveillance, patient monitoring, and outbreak management. Public health communication and policy enforcement, coupled with ethical and equitable considerations, are essential to mitigate the disease's impact and ensure societal trust. Together, biotechnology and technology provide a comprehensive approach to prevent, detect, and treat Dermaphyxia pigmentosum efficiently and ethically. Once again, this is Bioessential Task Force, and thank you very much.